Okay, so composition of functions. Another way to combine functions is through composition. So the function, take a look at it. We've got lots of brackets there. F, open bracket, g of x, and then that bracket's closed. So that's inside, right? If you think of order of operations, you do with brackets in the order from inside to out. And that's kind of similar here. But that notation is the composition of the functions f and g, and it's formed by substituting g of x for x in the equation for f, right? So you're figuring out what the value of g of x is and putting it into f. So how do we say that? We say f of g of x, okay? And sometimes it's denoted like this. So I always think about that little open circle as the O in the word of. So f of g of x. Sometimes you'll hear students abbreviate it to FOG because it looks like a little O, right? But when you write that, don't show it like this, okay? It's a little circle, open circle, but it's not filled in. And that means composition of functions, okay? So be careful, it's not to be confused with the product where it's a closed circle like that. All right, so let's do some work with composition. So we've got f of x and g of x. It says write the equation for h of x in terms of x if we're told to do this. Okay, so do not simplify. So this is saying, okay, h of x is f of, so I always myself convert this to the bracket form. Okay, so that open circle means the same as open bracket, g of x, okay? There's not a lot of space here, so I'm going to show my equal signs on one line, even though I don't like that, but I'm going to have to. So f of g of x is x plus 3, okay? Still not done, because now I actually have to substitute that in. So we did some practice like this yesterday. Right? We had a function and we substituted an expression in. So now in f, where are my x's? There's just one. So I'm going to put in a bracket where there's an x here. And now, so I'm replacing this with x plus 3, right? So I'll do it in red. So that's going to be x plus 3. And it says don't simplify, so we're just leaving it in vertex form, basically. Because it's a quadratic. So, name of the function is a quadratic. And it's in vertex form, so vertex there would be negative 3, 8. So sometimes when we're doing some math, we go back and review our previous work. So it says here, if h of x is the transformed graph of y equals x squared, describe the transformations. Use proper terminology you learned, well, in this course, right? In 20-1. So, always do stretches first. Now it says proper transformation terminology. To save time here, we're going to use abbreviations today. To save time and space. Right? So, still need to have the correct order. So that is a vertical stretch by 2. Okay, so I'm crossing that off for right now. Then it's negative, so that's a reflection in the x-axis. And then your translations. You're going left 3 and up 8. So horizontal translation, left 3, vertical translation, up 8. Again, a review from the quadratics unit. Point -24 lies on the original. determine its image after the transformations. It says determine, so let's show some work. So we start with -2, 4. Then we do a vertical stretch by 2, so we multiply that y value by 2. Okay, then we reflect in the x-axis, so we multiply by -1. And then go left 3 and up 8. We would end up at -5, 0. Okay, so again, review, algebraically determine the x and y intercepts, and then verify, we'll verify just when we graph. So x-intercepts is when y is 0. So we'll have 0 equals -2 bracket x plus 3 squared plus 8. Yep, you could expand it out and then factor it, but maybe it doesn't factor. So from here, I use the square root principle. So I would bring the 8 over to the left, divide by -2, take the square root of both sides, positive or negative. And then solve for x. So I'll get x, if I bring the 3 over, so it'll be plus or minus 2 minus 3. So that's going to be, I'm going to simplify those. So 2 minus 3 is -1. -2 minus 3 is -5. Okay. Now the y-intercept, I'll just do that over here. That's when x is 0. So I'm going to get y equals -2, 0 plus 3 squared plus 8. If you had expanded and simplified, then it would just be the constant term. But here, that's going to be 9 times -2 is -18, plus 8 is -10. Okay, so sketch the graph, labeling the vertex and all intercepts. We have a lot of information there. We also have the vertex form of it, right? So we know the vertex is -3, 8. We know the stretch factor is 2 and it's opening down. So over 1 down 2, same on both sides, or over 2 down 8. And that confirms with these, your x-intercepts. And your y-intercept is -10. So we could actually go a little further. And now join those up. Okay, I'm not going to get you to confirm your work with your graphing calculator. You can do that on your own. Okay. So, I was a little bit off here. Yes. Sometimes it's not. Okay. All right. So that's our composition of functions. So the function f of g of x is the composition of f and g, and is formed by substituting g of x for x in our outside function. In this case, the outside function is f of x. So again, that's read as f of g of x, and is also denoted 2 ways. So this way and this way. Vice versa, we could go g of f of x. So it's just switching the order. So that one we'd be substituting f of x or x into g, and don't confuse it with the product. So that's just an overview of what we do. Now we're actually going to do some work with it, and we're also going to look at the domain, just like we did with operations. Okay, so first thing, this is such good review of linear functions and quadratics. So state the equation of f of x and then of g of x. Doesn't matter what form for g of x, you could put it in factored form or you can put it in vertex form. Totally up to you. So if you do vertex form, then the vertex is at 1, -4. You take a look, the stretch factor is 1. Positive, so nothing in front. Okay, if you do factored form, then the factors would be x plus 1 and x minus 3. Again, nothing in front because there hasn't been a stretch. Okay, so either way. Now, you don't need the equations in order to answer the next question because we have the graphs. So it says state the value of f of g of -1. So that's going to be f of whatever g of -1 is. So you want to look at your g. When x is -1, okay, what's y? It's 0. So this is the same as f of 0. You're starting from the inside and working out. So now you go to your f here, and when x is 0, what's the y? It's 4. Okay, so you can't get the answer until you work from the inside out. So next one is going to be f of whatever g of 1 is. So we're trying to find this first. So g of 1, I'm just going to erase this. So g of 1, okay, what's y? It's -4. So this is going to be -4 now, goes into your x. Then you look on f for when x is -4. You go up and find the y value, that's 8. Then f of g of 0. So g, when x is 0, gives you a y value of -3. Okay. Then what's f of -3? So then your f, you look where x is -3, and you go up, it's 7. So show that step if you need to, right? Just to not lose track. And then f of g of 3. Well, what's g of 3? So g, when x is 3, is 0. What's f of 0? It's 4. So this one here is the same as this one, okay? Basically, because this 3 is an x-intercept in g, and so is -1, okay? Now look at the difference in the next one. Sometimes students get mixed up. They take a quick look at it and they start substituting -1 in for x. That's not what it's asking. It says state the value of x such that we get our answer of -1. So we're working backwards from 4. What do we get for x? 0, etc. So here, this is our answer. So I show it. I try to look. Okay, so for my f of some value has to give me -1. So now I'm working backwards. So when do I get a y value of -1 on f? So there's my f. When do I get a y value of -1? Right there. Okay. So when x is 5, I get y is -1 on f. So that means this is 5 in there. Okay. But I'm not done. That's not my answer because that bracket is g of x. So this is saying that g of x equals 5. Okay. So now I look at g of x for when y is 5, right? And there's 2 values. There's this 2 points. So this is going to happen when x is -2 and when x is 4. Okay? So sometimes you might have 2 values when you're finding x. Not for y, because these are functions. Okay, so then it says use all the values above to state points that would lie on the graph of the composition. So just make sure all of these are f of g's, and they are, and then plot them. So here, from this one, that would be -1, 4. From this one, it would be 1, 8. From this one, it would be 0, 7. From this one, it would be 3, 4. And actually, for this one, we have -2, -1, and 4, -1. Okay, plot them. -1, 4, 1, 8, 0, 7, 3, 4, 2, 1, 1, 1. Okay. So you can see it's going to form a parabola. One point that we don't have is when x is 2, but it's going to be symmetrical, right? There's your axis of symmetry. So we're going to have a point here. Okay. So now let's go back and do this in terms of x. So f of g of x will be f of what g of x, what did we say? It was -x plus 4. And then our f, we said, sorry, other way around, messed up there. F of g of x, we said it was x squared minus 1 all, x minus 1 all squared minus 4. Okay. So then f was negative, substitute that in, plus 4. So let's keep it in factored form because we want to check it with our graph. We expand out the negative. That stays negative. That'll be positive 4 plus 4 is 8. Okay, so this says the vertex is 1, 8. Let's check. 1, 8. Yeah, that's our vertex. That says it opens down, no stretch, and it matches. Okay. So we've looked at graphs, we've looked at discrete values within a graph, we've looked at the actual functions of a composition. Here we've got discrete functions, so just these particular values. And so basically this is saying, this is a fast way of writing out sets of ordered pairs, right? So for F, for example, would be the ordered pairs -2, 3, 0, 1, 3, 5, and 4, 0. Okay, you don't have to write that out. I'm just showing you that would be the long way of writing it. Then G would be -2, 0, 0, 4, 3, 6, 4, 0. Right, like that one that we reviewed from yesterday. So you can write it out as 7 ordered pairs. Right now it's in the chart. And then it says complete the table by stating the corresponding values of the composition. Okay, so this makes it, for some people, a little bit faster, right? So if we're finding f of g of x, this is for when x is -2. So we're really finding f of g of -2. Okay, well, what's g of -2? You will have to look at your g column and when x is -2, right? So when x is -2, g is 0. So this is going to be f of 0. And then we have to find what f of 0 is. So we have to look when x is 0, what's f? That's 1. So start out within the same row, but then sometimes you have to move to a different row. If you find that confusing, then write out the sets as ordered pairs. And do it like we did today's first question we did. So here, the next one will be f of g of 0, right, whatever the x is. So that's going to be f of whatever g of 0 is. So g of 0 is 4. Now we look at when, in f here, when x is 4, okay, what's y? It's 0. F is weird. Okay, so then f of g of 3. So when x is 3, g is 6. So that's f of 6. What do we do now? Is there an x of 6 there? No. So this does not exist. The end. Then f of g of 4. Well, what's g of 4? It's 3. Okay, so now we look at this column. When x is 3, that's 5. Okay. All right. That's what composition is. Okay, now we need to look at the domain of a composition of functions. So, just like we did with operations on them. So, says two functions are given, f and g, so one's a square root, one's a quadratic. State the domain of each of them. So domain of this radical function, remember this has to be greater than or equal to 0. So if you solve that, that's going to be x is greater than or equal to 3. Okay. Domain for g, all real numbers, right? It's quadratic. So what is the domain for if we're adding, subtracting, or multiplying? So remember, it's the overlap of all of the two different ones. So here, x greater than or equal to 3 is there. All real numbers is all of it. So where does it overlap? There. Okay, so this is going to be x greater than or equal to 3. Because if I had an x value of 1, I couldn't find, I couldn't evaluate f of x. So I wouldn't be able to add it, or subtract it, or multiply it with anything. Right? So it's where the two domains overlap. For division, then it's where the two domains overlap, but then we can't have, right, g of x cannot be 0. Okay? So when does that happen? G of x is x squared minus 1. So when does that happen? That means x cannot be plus or positive or negative 1. Okay? Well, is positive or negative 1 in this domain? No, so it stays the same, right? If this is our domain of all of the operations, or of our, basically our base domain, and then for division, we have to look at the denominator. In this domain, we're never going to get those anyway. So it's never going to be 0 on the denominator. So it stays the same. You do have to check. So now notice how we only needed the domain of the original functions to determine the domain of operations. For division, we also need some way of knowing what values of x makes the denominator, g of x in this case, equal to 0. So we can exclude them. Okay? So now we're looking at composition. So first of all, determine the simplified equation for f of g of x. So that's going to be f of g of x is x squared minus 1. Okay, so now in f, you replace x with the g, x squared minus 1. Right, so g of x is this. Now it goes in there. And just expand and collect any like terms if you can underneath the radical. The odd time you might be able to factor something and simplify it, but most times you won't. Okay, so yeah, you could factor 2 in that, but you can't take the square root of 2, so I just leave it. Okay, so if we use the same rules of operations, we're going to think that the domain is x greater than or equal to 3. Right? a question for you. Determine the value of f of g of -2. Well, -2 is not in that domain, but let's see. Can we get something? So -2 in for x here. Okay, so when we put -2 in for g, we get 4 minus 1 is 3. Then we put 3 in for f. We do get a value. So it does work. Okay. Oh, I switched these around. Okay, so I did this. Sorry, I did this. I'm going to just move this. You can just put an arrow. This is really for here. And then by determining, so that's what we did. We determined the value of g of -2. I want to go back to my function, which was root of 2x squared, and subtract it. Sorry about that, I was thinking ahead. I get the same value though. So, did you get same value? Yeah, I got 0 for both. Can you say that x equals, therefore you can say that x equals -2 should be part of the domain. So the domain that we said was x greater than or equal to 3 based on our work from operations. But this is not really just an operation. It's not adding, subtracting, multiplying, or dividing. It's a separate concept. So it's not going to follow the same rules for domain. So is our domain correct? No. Look at the simplified equation to determine the actual domain. So remember, that's 2x squared minus 8. Now you have to think back to that quadratics that we did, right? We know in order for this radical function to be to exist, that the radicand has to be greater than or equal to 0. So we have to solve that inequality. I would divide by 2. First, personally. Okay. You could bring the 4 over, but a lot of you, when we were reviewing for that and on that test, you forgot about the 2 cases when you did that. So I would factor this. And then remember, on a number line, okay, you're looking for, that's going to be a parabola that opens up, and we're looking for the x values that make it greater than or equal to 0. So these values here, these parts of the graph. So where is that? That's for where x is less than or equal to -2 or x greater than or equal to 2. That's going to be your domain. So the actual domain we had to look at the final version then. Let's take a look at composition of g of f of x. It's going to be a different function. Okay, so g of f of x. Well, f is the root of 2x minus 6. So that's what we put into g. Now, when you square a square root, the radical goes away. So we get 2x minus 6 minus 1. And that simplifies to 2x minus 7. So that gives us a linear function. Okay. So, totally different from the other. So composition, order matters. Is it f of g of x or g of f of x? Not like multiplying or adding functions. In this case, order matters. So from the last example to the left, if you just looked at the final expression to determine the domain, what might you think this domain is? So if we look at a linear, we think it's all real numbers. Okay. And that's kind of what we were, in the previous example, we used the final expression, right, to find that domain. So if we're thinking, okay, let's do that here, that's what we would get. So now here's an example. By substituting x equals 1 into the equation, so now I'm going to use this, I'm going to do it correctly. So there's my equation. So now if I put 1 in, I get negative 5. So I get an answer. That's all good. But what about if I put do it in order? So I go g of f of 1. Very good. Fix that up. So g of f of 1. Well, f of 1, let's go back to my f here. 1 in there is going to be 2 minus 6 is negative 4, right? So here, I would get the root of negative 4. Can't do that in the real number system. So this does not exist. Okay. So do you get the same answer? No. Therefore, we can say that x equals 1 is not part of the domain. So is our domain from the second bullet correct? No, because we said all real numbers. Okay, so what do we do here then? So we have to think about, this is really what's happening. So we have to think about what values of x are defined in the inside function. So that would be x greater than or equal to 3. So for f of x, x has to be greater than or equal to 3. Right? Anything that we put in that's greater than or equal to 3, we'll get a number out. Right? We'll actually get a positive out. Then when we put it into the squared here, right? So we'll get a positive out. You can put anything in here, right? So there's not going to be any restrictions on that. So this x greater than or equal to 3 is going to be our overall domain, right? We'll give values and g of x. Okay. So g of x is x equals the all real numbers, right? So it's where these overlap. Okay, so overall, it's going to be x, where x is greater than or equal to 3. So the important part is to look at that inside function, find, first of all, what goes in, and then compare, really what you compare to is the overall, the final. So that's kind of the trick way, not the trick, but fast way. Look at the inside, so this is what I would do. Inside domain, and then overall domain, okay, and where do they overlap? That will do it for you. Now, what's really nice is you have a graphing calculator. What happens with your graphing calculator, if you enter it as a composition, not as simplified, it will graph just what it's supposed to graph as a composition. So let's turn over the page. And this is going to tell you how to do that in your calculator. Okay. So just to summarize, the x value needs to be in the domain of f in order to be in the domain of g of f of x, right? So starting from the inside out. You may be fooled into thinking a restricted value is in the domain if you plug into the simplified form of the entire equation. So you just have to think about it. The domain of g of f of x consists of the values of x in the domain of f, for which f is in the domain of g. We're working from the inside out. Okay? So we can always check the domain for composition of functions using our calculator. So here's the example that we just did to graph this. So get out your calculator. This is going to be your friend when you're doing these for sure. Always a good way to check. Clear off any functions that you had in there. Let's put the first f into, so 2x, root of 2x minus 6. Y2 is x squared minus 1. Okay, and then they kind of use composition. They don't use f and g, but here we want to take this function here, right? So this is f of x. This is g of x. So this is saying find f of g of x. So you do use brackets, but you use your y. So how do you get those? Okay, well, you go bars. So bars for variables. Cursor right to y variables. Enter on that, and you'll see a y1. So choose y1. So enter on that. Then open bracket and do the same to get y2. So bars, y bars, function, down to y2. Okay, so that's going to graph for you f of g of x. So then it says graph only y3 by highlighting y1 and y2. Yeah, so basically here, it should be unhighlighted. Okay, so if you go up to the equal sign and enter on it, then the equal is unhighlighted or deselected, and so it won't graph it. It's a good way of keeping things in there that you don't want to look at, but maybe later you want to look at. Okay, so now if I, not trace, you can press graph. Make sure your window is a standard window. Okay? All right, so that was the first one, right? So that was f of g of x. So if I go back to my chart there, we did f of g of x to start, and we said our domain was less than or equal to -2, greater than or equal to 2. You can see it looks like there's a little gap there. If I press in trace mode, if I press 2, enter, it does go there. So your graph can't always get every single point. So always check that. Don't think it's missing the value of 2. It's there. Okay. Let's now go back to our y equals, and let's switch this around, right? Because you may have found that one okay by looking at the final, but this one, may have said the domain was all real numbers after you simplify. So now let's go and change this first one to y2. So vars, y vars, function y2. And the next one to y1. So vars, y vars, function y1. Okay, graph that. And there it is. It's not a line that continues on forever. Looks like you test that at x equals 3. It goes to that point. And we said the domain, after looking thoroughly at this, we said the domain was x greater than or equal to 3. Originally, we said all real numbers, right? But your calculator will show you. As long as you don't put in the simplified, I did not put in 2x minus 7. I put in the two functions separately, and then I did the composition. That's how your calculator can work. Okay? So that's a kind of a really nice thing. Okay, so okay. So we switched it. All right, next one, it says determine the equation for f of x in terms of x and state the domain. Verify with your graphing calculator. These functions are exactly the same. So this is going to be y equals f of root 2x minus 6. So now we're going to have a radical within a radical. There's really nothing you can simplify there. You can show it without the inside brackets. Okay. So, remember my little hint there? You look at the inside function, which is f of x, what's the domain? Well, that's going to be x greater than or equal to 3. And then you look at the overall, and you see where they overlap. So the overall is that whole thing. 2 root 2x minus 6 has to be greater than or equal to 0. Okay. So that's kind of interesting because that's a radical inequality. But we can isolate the radical. So bring the 6 over, divide by 2. And then, now you can square both sides, but you do need to be careful of the inequality sign when you do that. So what you might want to think about is our knowledge about radical functions. So you think about a graph. This here, when x is 3, y is 0, and it's going to be going up. So this is y equals root 2x minus 6. Okay, and when is that greater than or equal to 3? Okay, so we want to find this point here. So I'm going to solve the equation. Root 2x minus 6 equals 3. Square both sides. We've done that. Learn that. Okay. So it's equal at 15 over 2, and we want the graph to be above x equals 3, so that's going to be here. I'll maybe do it in red to finish this off. X has to be greater than or equal to 15 over 2. Okay. So where do these overlap? Well, this is 7.5. That's 3. So this will be your winner, right? Because let's say I chose 4, because I thought of this domain. If I put 4 in here, I get 8 minus 6 is 2. I get then 2 root 2, okay, which is going to be less than 6. So I'd end up with a negative. Okay, so I check these, and where do they overlap? Right, this one. So this is your domain. Okay. So let's see. I'm going to leave. I'm going to leave this for right now. So we're running out of time. Let's do a composition of 3 functions. So 6a. Okay. A radical, a quadratic, and a rational. Okay. So it's going to be f of g of h of x. So work from the inside out. Okay, let's see. Let it pause. Okay. So h is 4 over x. Then in g, I put 4 over x. So I have to square that. Which you could show as 16 over x squared. And then in f, I substitute that in. Okay. So that's going to be 4 over x. Okay. Notice that though, here, so 16 obviously squared is 4. Square root of x squared is x. But this number, if x was a negative, this would be squared, which would be a positive, so you could take the root and you would get the positive root. So really, we need an absolute value symbol around that x. We haven't, in math 10, we didn't really do that so much when we were doing square roots of variable expressions. But now that we're in grade 11, we're learning about domain and range in more detail. Got to be careful about that. Okay? Because it's not going to come out as a negative. In terms of, so the inside function is h, so that's everything here except 0. We just do all of the original domains. Okay. So we can put anything except 0 in. Okay. And then squaring it, that's all good. What we get out, though, is going to be positive here, but that means we can put any all real numbers except for 0 in. So in this case, our original was this, our final was all real numbers. So overall, it's going to be this one. Okay, and you can check. Let's check it on our calculator. There's a couple minutes left. So the domain on this one isn't too bad. So here, I'm going to change this to root x. Next one, just x squared. Clear that. And then 4 over x. Okay, so then we're going to do, so y1 bracket, so let's just see here, y for bars, y1 bracket, y2 bracket y3. Close bracket. I think that will do it. And then we go up and select. Okay, still focus. I know it's a long one, but we're getting through. Okay, you can see an asymptote at x equals 0. Okay, so overall, this is our domain. Okay. All right, so then I'll leave this for you to do, but something to note here. So see how I took the square root of x squared? That's going to be absolute value of x. Okay, x can be all real numbers. If you take the square of the square root of x, that's equal to x, no absolute value, right? X has to be positive to start, not all real numbers, because you have to think about doing this before simplifying. You can't take the root of a negative. So x has to be greater than or equal to start, then you get x here. So again, it's like a composition of functions. Inside function, outside function. Okay? So we'll leave it there. You have a few minutes to spare. And then so tomorrow we'll finish up the last part there, final.